Hello, it's James from XRobots.co.uk. This is part one of Iron Man versus the Mantis robot. I'm here with Matt Denton, who built the Mantis robot and is also part of the creature effects team at Pinewood Studios, who built the real BB-8 seen on stage at Star Wars Celebration at Anaheim and the movie droid. Have a look in the links in the description to this video for more information on that. In part two, I'm going to drive the Mantis robot dressed as Iron Man, but in this part we're going to get it off the trailer and have a look at the tech spec.
Okay, so let's go for a start-up. Good start. Right, so I am going to go into jog mode using the touch interface. I've got a touch interface to my right here,
Okay.
which is like the main computer display, gives me all sorts of information. It's like a bird's eye view of the machine, so you can see where all the legs are and what have you, and it lets me select various modes and gives me feedback for all sorts of stuff, including how much load the legs are taking, that kind of thing, any errors that come up. It also doubles as a dashboard of a car, so I can select this screen here and actually you'll see there's like the engine RPM and the oil pressure and how much oil flow, things like that, which I also have on this screen here, which is like a sort of a more basic version of it. So I've got kind of a bit of redundancy here. So the first thing I'm going to do to get it off the trailer is, what I have to do is put each leg into manual jog mode, and when it's in manual jog mode I can use the right hand joystick down here to effectively drive each axis of the leg, so it is really the most basic form of control. And I just pick each leg up, make sure it's working and move it slightly away from the trailer. Once I've done all 6 legs, I then select the highest position mode of power up, and effectively the hexapod will come down and find the floor after it's reset all the legs into its neutral pose, touch on the floor, and then when I'm ready it'll then lift itself off the trailer. At that point I've then got to get off the trailer, take the car out of the way, get back into the cab and lower it all back down again, or shift it to the side in this case. So I'm going to start on each leg, swing her out, move it in. I'm just going to drop that down a bit as well. Yeah, that's good. Okay, I'm going to go to the left side now. So I'll start with the left rear leg. Okay. So now it's going to lift all the legs into their neutral position. So it's finding their neutral X and Y position. Right, so now it is telling me that one leg's still in contact with the ground. So that's that one I'm saying about, which has got this weird thing, so I might have to address that before we go any further. Oh god, that one's super tight. -1. Oh, nope. Oh. 92. 92, right, so that one was super tight. So I'm going to round that one back up until it hopefully. So that's the next power stage coming on there. You heard the engine slightly load up. So first it lifts the legs and then it neutralises them. And now it's going to go on terrain search, so it's going to go down and try and find the terrain. Okay, it's pretty good. Now I'm going to slew the body up into its neutral position, which is the high position. This should lift it off the trailer. Okay. So that leg that we adjusted is reading a slightly high level, which might cause us a bit of issue, but we can see that in a minute once I've moved the machine around. I'm just looking at all the other legs at the moment. It's reading, you know, like about 100 kilos more than it should, but that's probably again down to that calibration not being quite right. So now I'm just going to move the car out of the way. It's like a little body warm up, which gets all the joints moving. There's our 3 degrees of freedom in that axis. Okay, seems pretty good. The foot contact pressure is about the same as a human foot, so you'll see that it barely does anything to the grass, and the grass just recovers afterwards. Just these little round circles in the grass. That's very kind to the terrain. Now I've put the joysticks back into body control, so I have 6 degrees of freedom with the body, so it's a bit like a simulator machine, a Stuart platform, let's say, but on legs. It's a mobile Stuart platform, and that's really useful because you can imagine if I had a tool on the front of the machine, like a set of forks for lifting, or a grabber, or a digger, or something, anything on the front, I can actually use the body itself as part of that tool, so that you can move the tool into position, or use it as part of an extra degree of freedom with the tool by moving the cab around. And that's just 3 degrees of freedom. Of course, I've got the translates as well, so you've got a really mobile tool on the front of the machine now, and you can do some very wacky things. So that's 6 degrees of freedom in the body. And you can, sometimes I can coordinate them together to do something that resembles. It has like a safety feature as well, that if you try and move the joysticks too fast, it effectively just stops where it is until you catch up with where you left it. So you can't just bang a joystick over to one side and fly out the window. Obviously it's an omnidirectional machine. You saw me turn around, I can walk forwards and backwards, I can sidestep left and right as well. It's fully omnidirectional. And obviously I can select how many legs I move at a time, I can select how fast they move, and I can do things like change the step height, so I can make a much higher step if you're going over rougher terrain, or a much shallower step if it's flat terrain, so it keeps it more efficient. And then the other thing I can do is take control of the leg, so I can tell it that I want manual control of this left front leg, but the difference being is that rather than controlling each joint, I'm actually taking control of the foot position in X and Y axis, and it works all the kinematics of the joints out as it does when it's walking. So I'm just going to tell it to lift straight up, and the foot comes straight up in the air, and if I push forwards on the stick, it goes straight forwards with relevance to the machine body, reference to the machine body, using all 3 axes, or straight back for example, or I can go straight out to the side. So effectively I'm now using this, you could have a manipulator on the end or something, let's say, or a digging arm or a crane or something like that. The other thing it's doing, you might notice, is that the foot itself, as it comes up, the whole machine rears up, and that's because by using all the other legs in unison, you can get a much higher reach. So if I was only using this leg, I'd run out of reach because the cylinder would have bottomed out. But the machine itself uses the other legs and starts to lift the front of the machine up in this corner. So now I can get a much higher reach because the machine keeps going up. Every time it runs out of room, it pumps the machine up a little bit higher. So you can get this really wacky angle now. And it's the same with left and right and forwards and backwards. The machine actually skids to the right, the whole thing starts to move. So you've got effectively all 18 cylinders working in concert together to try and achieve this movement. And to do that you need quite a high degree of accuracy. And I can kind of demonstrate that by, if you imagine now underneath that foot that's in the air, there's an invisible rock. And we can't see the rock, but it's definitely there because that foot's placed on it now. And what I can tell the cab to do is, I'm fed up with being up in the air like this and I want to be level to gravity, so I'm going to get rid of that shift in my pitch and roll, which I'm all over one side, but that foot should not come off that invisible rock. It shouldn't change in height at all.
So can I get under there? Would that be unsafe?
That would be unsafe. That would be very unsafe. We could put a box of eggs under there though, for example,
okay,
and they shouldn't break. So I'm going to press this button now and that foot should not move from that position.
But it's levelling out the cab.
It's levelling the cab out, but that foot's staying on that invisible rock, as if it's actually stood on a piece of ground.
It looks uncanny.
Yeah, it's just a bit weird, isn't it? So that's the kind of level of control you have to have on a machine like this. If you didn't, all the hydraulics would tear each other apart. so because there's an awful lot of power in them.
So this here is like a long-range Wi-Fi unit, which is effectively a massive antenna and a little Wi-Fi device which goes down underneath the chassis here, and there's another box down here which is like an industrial router, let's say, which connects the cab unit, the Wi-Fi unit, and there's another little UDP wire there for diagnostics that I can plug into if I need to.
So then, in the back of the car, we've got
Another
some very familiar controls, yeah.
So we've got exactly the same thing again. It's my spare set of controls I use for development when I'm simulating the Mantis in software, and it's exactly the same version of what's in the cab. All I've done is I've unplugged the cab one, so we can see this one. Let me have a look at the engine display. Back to the start there, and same set of controls. It's also good to have a spare, of course, in case anything happens to the one in the cab. And all we've got here is a power supply that's running off the boot of the car there, a little mains inverter, just because this whole lot here runs off of 24 volts, which is plugged into a little mains unit over there, and one of these little TP-Link Wi-Fi units, which is effectively joining the Mantis to this console.
Right, so I've seen this is the main engine of the Mantis.
Yep, this is the power plant. So it's a 2.2 turbo diesel Perkins engine, and it's generally used for things like generators, electrical generators, for example. It is actually also used in off-highway equipment like JCBs, things like that. And it's called an industrial power unit. And what's nice about engines like this is that effectively it comes with everything bolted on it, more or less ready to go, so radiator and filters and what have you. And it has just 4 mounts that you bolt down onto whatever it is you're trying to do. And you bolt on what you want on the end of it. So it's a very easy way to get going, and being a diesel engine it needs a very minimal loom, an electrical loom, which is the only bit you have to add.
Okay, so presumably this is running a hydraulic compressor or a hydraulic pump.
Yep, this is running, so 2 hydraulic pumps attached. So you've got the main pump here. This is a variable displacement pump, and what that means is that it has a series of pistons on like a swash plate, and so it can deliver, it will keep a set pressure in the system, so as the flow varies it will swash the pistons back and forwards and vary the displacement of the pump, giving much more efficiency. As opposed to like a gear pump, which is actually the little pump on the back there. So a gear pump will just give a continuous flow, and any excess flow would be pushed through a pressure release valve, which is just a waste of energy and just creates heat. So it's a fairly efficient way of powering the machine. And the main variable displacement pump gives the flow to all of the legs and all the main hydraulic system. The gear pump at the back is just for the cooling circuit, so it's a low pressure system. It's called offline cooling and filtration, so it drags oil out of the pump, pushes it through a big cooler in the top here, through the filter and then back into the tank again. So it's a twin pump system, but the second one is just for cooling. Above the pump we have the engine control unit, and again, this is another one of my designs, because you can get engine control units, but nothing that I could find that off the shelf that would suit all of my needs, so I ended up having to build that as well. It's a microchip PIC based system. Most of my stuff, the microchip controllers I use are microchip PICs, and it's probably a DS PIC in there, sort of 16-bit or something. It sits on a CAN bus, so it can talk to the main control computer. It also delivers information to the driver panel, and that's where all the key start and engine heat preheaters and all that kind of things are. It's effectively tied into this box down here, which is like a little engine control box, which is just solenoid switches really, just to click on and off the main starter motor and preheaters. That's a fairly simple unit. And it's also connected in via CAN bus to the hydraulic control unit, which is again a piece of kit which monitors all the hydraulic system, like system pressure, system flow, and also controls this valve up here, which sets the system pressure. And this is like a little proportional pressure release valve, which takes a 0 to 10 volt system. There's a little solenoid driver up here, and that sets a pre-pressure on the pump, which effectively keeps a constant pressure, so you can set it by changing the voltage from 0 to 10 volts. Okay, so here underneath the tank on this side, this is the left middle legs valve rack. There's 3 proportional hydraulic valves here, and underneath each one of these valves there's a safety shut-off valve. When the E-stop is hit, basically all ports are closed, so the leg will freeze in whatever position it is, so the machine won't sink to the ground. So each leg has one of these racks, and that is supplying or connected via the hydraulic hoses to the 3 hydraulic cylinders. So there's the coxer cylinder that swings the leg back and forwards, then there's the femur cylinder which pushes the femur up and down, and then there's the tibia cylinder which pushes the tibia in and out. That's the 3 hydraulic cylinders per leg. Top pressure on the system is 165 bar, about 165 to 170 bar, and the pump can deliver about 150 litres a minute. So it's a fairly pokey system for a very small size vehicle. I'll just give you an example. So at 150 litres a minute, you'd size your hydraulic tank usually about 4 times the flow rate. So you'd have like a 600 litre tank of oil, so the oil has enough dwell time in the tank to cool down. We have a 70 litre tank. So you can imagine if it's running at full tilt, that tank will empty and replace on a very irregular basis, so it's like a real swirling vortex inside of there when it's going full tilt. So down here we also have the brain, which is what I call the hex engine, hexapod engine, and this is a port of my original hex engine that used to run on a PIC controller, but it was ported to Linux. So this is kind of a stripped down Linux box running on a x86 kind of PC104 module, which is clocked at 800 megahertz. So it's kind of like a turbocharged 486 computer in there, which is more than adequate to do the kind of maths involved in this. And this PC104 computer has a dual CAN bus on it, and this runs off around the Mantis control boards. So this is on that CAN bus is the engine control unit, which we talked about earlier, and the hydraulic control unit. But also every leg has like a valve control unit, if you like, and you can just about see one down there, which is the middle leg valve control unit. So again, that's all on the CAN bus, and inside of there is another DS PIC 16-bit microcontroller, and each one runs up to 4 PID loops, because you can actually have 4 valves per rack. Because there was the 4th cylinder originally on the leg. So it's doing the PID control loop for each axis on the leg, and also getting feedback from sensors in the leg. And there's like a chunky multi-way cable that comes out of that valve controller electronics there, and comes through the system here, down through the leg, up through the bottom and into this little chap here. And this is basically the signal distribution unit. And if you look down the top there, you'll see all the cables plugged in, and all of this stuff had to be IP65 at least, so it's all kind of rainproof and washproof and what have you. And what that effectively does is have the actual sensors plugged into it, including the encoders, and you can see one there. So this is an absolute encoder which closes the loop up for position feedback, and so that's your final part of the feedback system on the leg. In the cab on the right hand side, this display I call the BEV, and it's short for bird's eye view, and it's the main display computer which pretty much tells me everything that's going on in the machine, and as its name suggests, gives me a bird's eye graphical view of the machine itself. This particular control actually has 2 extra controls on it. The left hand side doesn't have this. Again, inside of here is another one of my designs, which is another PIC processor which sits on another CAN bus. That CAN bus only talks to this because it has its own little CAN bus system which just sends back all these buttons and joystick information to the main computer here. And what I should say actually is that this computer is connected to the hex engine via Ethernet. You might think, why use Ethernet? A bit weird, but that's because it has it built in, and it also means that all the control signals to the hex engine, i.e. how to drive the machine, or the interface, effectively is a headless system, the hex engine is. So the head of the system is here, and I can take this off of the Mantis and drive it remotely via a Wi-Fi link because it is Ethernet. So you can just replace that cable with Wi-Fi. So when this control is being used, the right hand stick is actually set up at the moment to do body rotations. So you get pitch, roll and yaw, which is a 3-axis joystick. These 2 levers over here are analog levers with like detents on them, 5 positions. One is the height of the lift of the leg, so the step height, and the other one is the speed of transition of the leg, so transition speed, so how fast the step takes place. And then all the buttons, which I like not to label just to confuse people. Anyone tries to drive it away, it's just about impossible. But effectively, these 3 here are options on the screen. So whenever you select something, if the screen needs to get confirmation, it'll be a green, a black or a red reply, and there'll be 3 pieces of text associated with the 3 replies, and it's always green, black or red. So maybe yes, no and abort, for example, something like that. The other buttons on this side of the control, this actually adjusts the height, so you can trim the height of the machine going down or up. I think this moves at about 25mm at a time, about an inch at a time. These 4 blue buttons here are a bit like a gear selector, and they change the walking mode, so that would be 1 leg, 1/2 legs, so there's a slightly different gait, that's 2 legs at a time. The 4th one is like a ripple gate, so it's actually 2 legs at a time but with a slightly different phase shift. And then this is called the shift key, so it gives a second function to all the buttons. And the shift in the first button puts it into the tripod gate, which is the fastest on a flat terrain. The orange buttons are used to select individual legs, so that would be like select the right front leg for manual override, for example. And that's reflected on the other side, on the left control, which we'll look at in a minute. Again, give me a control of the 3 left legs if I want to take manual control of them. The little button down the bottom literally switches the joystick mode between relative and absolute control. So when I'm in pitch, roll and yaw, I usually work in absolute control, so you have to hold the joystick wherever you put the joystick the machine is. But you can go into relative control mode, and then you can just nudge the machine and it will stay in its last position and nudge it back again. And if you want to just get it back to center up, you can actually use a shift key and one of the yellow buttons, and the whole lot will just center back to home again. So this side is like the dashboard of the car again. This is one of the first bits I made, and this connects directly into the engine control unit, and there's a little serial interface that comes up this connection along with a load of wires for the various buttons and key ignition switch. And the little serial cable talks to this serial based LCD interface, and so you get all this information displayed again, like engine speed, oil pressure, temperature and what have you. So the oil is currently at 35 degrees. You can manually override the pressure as well, so you can set the hydraulic pump pressure for testing. When it's in the position 0, it's under computer control. And so that's like preheat on a diesel car. You don't have these anymore, they do it automatically for you, but on old engines you'd preheat the diesel heaters and then start the engine up. And then the left hand control, similar to the right one, but it doesn't have the 2 joysticks at the top. So again, it has another 3-axis joystick, and this joystick is used for walking, so the walk direction, and obviously it's proportional, so you get a proportional step size according to how far you move it. And also by pressing this top black button here, it switches between walk mode or body translation mode. So that would be translating the body forwards and backwards, left and right, and twist is up and down. So again, you can adjust the height of the machine here. And similarly to the right hand one, you've got absolute or relative control modes. So you can just do little shifts in relative mode and leave it where it is, or you can go to absolute mode and then you just hold position wherever you leave the joystick. As mentioned over the other side, these orange buttons allow me to do individual leg control. The yellow buttons on this side, one of them is the body leveling function, which we saw earlier, where it'll level out to gravity. Actually, I didn't point out earlier on, but also connected to the hex engine is a little tilt angle sensor, which is via a serial 232 port. The 3 buttons up the top here, actually one of these is the power up button, one's the power down button, and the middle one selects whether this is walk or translation mode. The blue buttons on this side, do you know what? I never remember what they're for. Ah yes, I remember. It's because I always use the computer screen version of these, and this is to select the various leg configurations of the machine. So when we powered up, I had it in the high configuration. Currently it's in its standard configuration, but you can also select its narrow configuration if you want to go through a narrow gap. And so these can do this via button presses here, but you can also select that on the screen, because the screen is a touchscreen interface. So there are more buttons than what show. This little box down here is actually it's another one of these. The same device sits inside the joystick controllers. When I make boards, I try to make them multi-function. So it has like analog inputs to it, but it also had digital outputs. And although they're not used in the joystick control units, it's being used, the digital version of it here, the digital outputs are being used on a batch of relays, and this switches on things like the headlights, the side lights, and various other little bits and pieces that just need clacking on and off. Again, sits on the same CAN bus, so the main Windows CE computer up here sends data down to this one, and you can turn off various incidental things like lights and horns and stuff like that. The little box sat next to it over here is actually like a computer interface to the main CAN bus on the hex engine. So that's the CAN bus connector, so I can connect in via computer there and actually take control of the legs on the CAN bus if I switch the hex engine off. The little one next to that is a little serial bus, and that enables me to connect to each of the valve controllers, which we talked about, the PID controllers inside of each leg. And using a little rotary switch on the side, you can select which leg you want and then plug the computer in to update the firmware. So otherwise you have to take all the panels off to get to the PID controllers, so it's a fast way of doing a firmware update. There we go.
That is the end of part 1. I hope you've enjoyed the overview. Check out the links in the description for more information on the Mantis robot on the Facebook page. And don't forget to watch part 2 for lots of dressing up.